All right, before you get into notes today, I think it's best to try some explore problems first to kind of see what absolute value graphs look like before we kind of formalize it down. So do this work on scratch paper. Make sure that I see it so I can give you credit for it in your makeup work. But basically follow these instructions here. We're going to use Desmos to graph f of x equals the absolute value of x. So if I go over to Desmos, we go f of x equals the absolute value of x. And we should be able to make some observations about this and jot those down. So describe the graph on some scratch paper. So if I were thinking about it, I'd say, hey, these lines are both really straight. And notice how they kind of bounce back at 0. They're reflected there. One thing I want to point out, and I did in class, is that, hey, for every y value, let's say y equals 2, there are 2 x values, right? -2 and +2. Okay, that lines up with what we talked about yesterday, where there's 2 answers, there's 2 values of x for every equation we get. And we'll kind of see that play out more. But if you go through and add a new graph below it, f of x equals the absolute value of x plus 3, okay? Now I want you to answer what changed. Write down what changed about that graph. And if I'm looking at it, it looks like we shift up 1, 2, 3 locations. So there's something about that placement of that 3 that impacts the shape of our graph. Very similar to what we did with translations, right? Where if we added 3 at the end outside of our parentheses, it shifted the graph up. So you'll kind of repeat that process for the rest of these graphs here. X minus 3, x minus 3 inside our absolute value, x plus 3 inside our absolute value. And of course, we want to see what the negative looks like as well. Once you've done that, go ahead and pause your screen right now, unpause it once you've done it, and come back and we'll jump into the notes here to kind of formalize what we learned. So we're going to take what we learned in those explore problems, and put it into some notes. So first thing, I want us to kind of sketch what that absolute value shape looks like. Right, so we came in at a decreasing straight line until we hit the origin, bounced back, came out, and it kind of reflected perfectly. And we should have arrows at the end because they should go on forever. And again, that kind of reflects the idea that we're going to have 2 solutions to every problem, 2 values of x for every y value. Now, if we want to fill in this table, this basically summarizes what we did in each of our different graphs here. If we took f of x and threw a negative sign out in front of our absolute value, it flipped the graph upside down. If we took f of x and added 3 outside of our absolute value, it shifted added c outside of our absolute value, it would shift that graph up c units. So in our case of the Desmos, when we did that, it was f of x equals x, absolute value of x plus 3. It shifted the graph up 3. So to shift it down, we used a subtract c at the end. So f of x equals the absolute value minus c. To translate it right, we subtracted c on the inside. Again, similar to our translations, it operated the opposite of what we would expect. X minus c, moved it to the right, and f of x equals absolute value of x plus c, and our absolute value shifted our graph to the left c units. So it's important that we have an understanding of the shape of absolute value, recognize what it is, recognize the significance of the structure and how it moves around. We'll do some matching problems just so you get more work with this when you get into practice. But we can move on to kind of what we're going to use these graphs for in this class. And we are going to use it to help us solve equations. So we solved equations yesterday. We're going to build the complexity of those equations. And it'll be helpful for us to use graphs to solve it. So jot down these 3 steps here on your note sheet. First off, we're going to treat each side of the equation as its own function, then plot into Desmos. So I'll show you what I'm talking about in just a second. Then we're going to find the intersection of the two functions, just like we did with our systems, solving systems of equations. But instead here, since we're using this as a tool to help us solve equations, we're only going to pull the x values. The x values are the solutions. So let's see what I'm talking about in example 1. In example 1, we have 2x minus, absolute value of 2x minus 3 equals 1. And we know from yesterday's work that we should be getting some x value equals, and then some x value equals, right? We should get two different answers. If we went through the math, we would see that, we'd see that we would get 2 and 1 as our final answers, just like we did yesterday. But let's kind of do this graphically first. First thing I'm going to do is I'm going to treat one part of my equation. I'm going to call that f of x, and that'll be the first thing I graph. Second thing I graph here is that other side of the equation. I'm going to call that g of x. Okay, then we're going to go into our Desmos software. We'll put my f of x in. That was, we said, absolute value of 2x minus 3. And we said our g of x was 1, I believe. Yep, g of x is 1. And now we have this system graphed, and we can find the solutions for it at the intersection, right? We have an intersection at 1, 1. We have an intersection at 2, 1. But since we're looking for just the x values, right? We're trying to solve this original equation, 2x minus 3 equals 1. We are just going to pluck those x values, so 1 and 2. So our solution here is x equals 1 or x equals 2. Now, moving on to example 2. If you want to start trying this on your own, pause your screen, unpause it to test against mine. We're going to just start by kind of splitting this equation into two separate ones. Let's call f of x the minus x plus 5. And let's call our g of x, this absolute value side, the 3x plus 1, the absolute value of 3x plus 1. I'm going to go into my Desmos. I can clear off my old graphs. We'll have f of x. And let me go back and look. That equals negative x plus 5. And our g of x is equal to the absolute value of 3x plus 1. Let me just double check, make sure I put that in right. Yep, I did. Cool. Now we have another system where we can look, and we're looking for those intersections, right? And ultimately we're trying to find the values for x. So if we click, we can kind of click on these dots and hold them up there. We have negative 3, comma 8, 1, comma 4. My x values are negative 3 and 1. So that's what our solutions are. Go back here, let's write those in. X equals negative 3 and x equals 1. Now, this really helps us out when we get into things like examples 3 and examples 4, where we have a really complicated system going on. And instead of doing the plus minus of this polynomial and then solving for 0 on one side and factoring or using the quadratic formula, let's use the tools we have and let's just get this onto a graph, find our solutions graphically, and save ourselves a lot of time because we already understand what the concept of these solutions are. So I'm going to call this polynomial my f of x here. I'm going to call this absolute value side my g of x. And if we graph those and find the intersection, we should be able to find our solutions. Let's go ahead and do that. I believe that our f of x is x squared plus 3x plus 4. Let me double check, make sure I did that correctly. Awesome. And my g of x is equal to the absolute value of x plus 4. If we look here on our graph, we indeed have two intersections. We have two solutions. It looks like they happen at negative 2 and 0. So my solutions there are x equals negative 2 and x equals 0. Okay, example 4. Let's test this out. It doesn't matter which one we call which, and so let's mix it up a little bit. Let's call my f of x the one on the right. And let's Let's call this one on the left h of x this time. It really doesn't matter what name we give the function, as long as we understand that, hey, we're graphing two separate functions here. So let's graph that f of x first. I'm going to clear out my work. F of x equals negative x minus 2. Let me double check I entered that correctly. Awesome. And h of x equals, looks like negative 2, the absolute value of x, and minus 3. Now if I zoom out here and look, it looks like we actually don't have any intersections between our graphs. If I zoom out even more and more, it looks like they're getting further away down on the right. And so let's recall back to our systems of equations while we were working. If we don't have any intersections, it is no solution. So no intersections. That means no solutions is our final answer. So when you get to the practice problems, you should be able to cruise through tier 1 and tier 2, no problem. And then tier 3 and tier 4 are nice review problems for us to kind of make sure we're continuing to spiral the skills we learned in our previous lesson.